Okay, last video here. We're going to try to make this quick. We're going to cover buffers in the body. Specifically, we're going to focus on our main buffer system, which is in our blood. So I have the generalized equilibrium reaction here for a weak acid and Henderson-Hasselbalch equation, but what I want to focus on is this right here. The body has three main buffer systems. So proteins are actually a buffer system because they can act as acids or bases depending on specific groups within the protein. So you don't have to know everything there is to know about protein structure, but there are different acidic and basic groups within a giant protein molecule that could give away a hydrogen or receive a hydrogen, and therefore they can play the role of a weak acid or a conjugate base in any biological system. So proteins are a first buffer system of sorts. There's a phosphate buffer within the cells, okay, which is this right here, H2PO4. This is the weak acid. And that makes HPO4 minus 2, the conjugate base, right? And that's within cells internally. And then lastly, there's the bicarbonate buffer in your blood, which is this reaction right here. It's carbonic acid breaking down into bicarb and H+, okay? And I wish this was all to the story, but because H2CO3 is unstable, the equilibrium really looks like this, meaning it can break down one way into carbon dioxide and H2O. It can also break down another way into bicarb and H+. So if it loses both hydrogens and an oxygen, it can make water, CO2 as a byproduct. And if it just loses one hydrogen, disassociates with just one hydrogen, it can make bicarb and H+, all right? So this right here is our full blood buffer equilibrium system, okay? And this equilibrium is crucial for maintaining proper pH balance in the bloodstream. So pH of the blood, we call it physiological pH, should be held right around 7.35 to 7.45, okay? So make sure you know the range for physiological pH for exam 4. All right, so let's look at how our blood buffer is affected and how it responds to specific changes. These are not all the changes that could be thrown our way, but some of them, and we'll see how it responds. So changes, one, in breathing will influence blood pH. Okay, so you can see here we're going to look at what happens if we decrease respiration or increase respiration. Obviously, that's going to affect the amount of CO2 in our blood. So we call this, it can lead to a state of high pH or low pH, and we call respiratory alkalosis. This is kind of a word that means more basic. This would be too high of a pH in our blood, caused by changes in breathing. And respiratory acidosis is a state that leads to an acidic pH in our blood because of certain respiratory issues. These can be corrected by shifts in equilibrium, so I'm not going to say which way it would need to shift because it depends what the situation is. It would shift different ways depending on if you're in a state of alkalosis or acidosis. And also help from the kidneys. Because you see here, via this arrow, the kidneys can pull bicarb out of the blood. That would cause a shift in equilibrium. Or it can dump bicarb into the blood. That would cause a shift in equilibrium. So here's what I want to remind you of before we jump into these things is Le Chatelier's principle. If you are rusty on Le Chatelier's principle, how changes in concentration affect equilibrium, either with products or reactants, you need to go review that. I would pause this video and go review that, and then come back and finish this video, because that's what we're about to get back into. But changes in kidney function influence blood pH as well. Okay, so kidney failure usually means acidosis, and that can be corrected by your breathing, and shifts in equilibrium as well. I'll put EQ, right? So There's a few external factors as well that influence blood pH. So metabolism has an effect on blood pH because the more we metabolize food, drugs, things that we put in our body, that normally increases the amount of acid in our body. Other factors such as what we eat, any drugs that we take, can affect the amount of acid in our blood as well. Okay, now remember, H plus here is how we're judging pH. So our levels of H plus affect pH. So remember, I'm going to write these relationships out. An increase in the concentration of H plus lowers pH. This is a very important relationship. And a decrease in the concentration of H plus raises pH. Okay, so definitely know these for the exam, for exam 4. All right. And this system right here, we're viewing it from the viewpoint. This is the reaction in our blood. So this is from the viewpoint of our blood, okay? So what we're going to do next is walk through a few scenarios and see how that would shift equilibrium and how that would affect our blood pH, all right? So the first question I want to ask you is, what happens to blood pH if you hyperventilate? If you hyperventilate. So when we hyperventilate, we're breathing really fast, okay? We're exhaling a lot of CO2 in the process, an abnormal amount, okay? So notice, it says here, if we increase respiration, this is right next to the downward arrow, because what that means is that we are exhaling CO2, okay? Meaning CO2 is leaving the blood, okay? That's why the arrow under CO2 is pointing away from the blood buffer system. So if we're hyperventilating, we're breathing really fast, CO2 is leaving the blood. So I'm going to put a little downward arrow next to CO2 because the concentration of CO2 in our blood is going to decrease, all right? So I'm going to also write that down here. If we decrease the amount of CO2, we're ultimately trying to say what's going to happen to blood pH. So we want to ultimately see how that's going to affect H+, okay? So if we, according to Le Chatelier's principle, if we decrease here, it looks like a reactant. Which way would equilibrium shift? It wants to restore the thing that's decreased. So equilibrium would have to shift to the left. Okay, the only way it can do that is by internally taking some bicarb and some H+, reacting them, making carbonic acid, which would then break down into CO2 and water. Okay, to do that, we have to use up some H+. So if we're going to use it up, the concentration of it in the blood is going to go down. All right, so if equilibrium shifts to the left, then the concentration of H+ is going to go down. And remember what we wrote up here? Concentration of H+ goes down, then pH would go up. Or you could say pH will increase. Okay? That's one scenario. Now, the other scenario, what happens to blood pH if you hypoventilate? Okay, this should be an opposite of what we just walked through. So I'm going to erase all that. If we hypoventilate, that means we're breathing really slowly. Okay, so if we decrease respiration, we're not exhaling CO2 at a normal rate. It's at a slower rate. So from the standpoint and viewpoint of your blood, the amount of CO2 in your blood is not, it's going to be elevated because we're retaining more CO2 because we're not breathing it out at a normal rate. We're slowing down our respiration. So an elevated amount of CO2 in the blood would cause, we can write that down here as well, would cause your equilibrium in your blood to shift which way? We now have an elevated amount of CO2, which would cause equilibrium to shift towards the products because we're going to use it up, okay? CO2 plus water will make more of our products, okay? Because we don't want too much CO2 in the blood. But what that's going to cause is equilibrium to shift to the right. If equilibrium shifts to the right, we're going to make more bicarb and more H+, all right? If we make more of these things, we're going to have a higher concentration of them than normal, all right? So we're going to have a higher concentration of H+. And what's that going to do to pH? More H+ means a lower pH, okay? So you can say pH will decrease. Or it would become more acidic. Here you could say more basic. Oops. Okay? So that's hyper and hypoventilation. Last two scenarios, and that's it. This is the last slide. what happens to your breathing rate now? We're going to look at from the kidney standpoint. So if your kidneys cannot store bicarb, HCO3 minus, all right, so if this function is shut off, maybe we need to store bicarb. Store bicarb means we're pulling it out of the blood and we're storing it in the kidneys. And if your kidneys can't do that, then we're going to have too much bicarb in the blood. So if we have too much bicarb in the blood, okay, if we have too much of this, our blood could respond by doing what? The only thing it can do is shift equilibrium. Well, we don't want to shift equilibrium this way and make even more bicarb. So the only thing we can do is react bicarb with H plus and shift it this way towards CO2 and H2O. So equilibrium will shift left, and the way it will do that is by reacting bicarb with H plus. If those two things are reacting, we're using them up. Okay, we're using them, we're reacting them. So the amount of H plus is also in the process here, due to an elevated amount of bicarb, the amount of H plus, which has not been messed with, is going to go down because of our equilibrium shift. All right, and if H plus goes down, what's going to happen to our, I'm working this as though I'm trying to answer a pH question, which could be a valid question, okay? pH would then increase. Whoops. But I just realized that's not what the question's asking. It says what's going to happen to your breathing rate. Okay, so let's go back here. If equilibrium shifts left, that's going to elevate the amount of CO2 in our blood. Okay, that should look like an upward arrow, and it doesn't. If we have an elevated amount of CO2 because equilibrium shifted left, then our breathing will respond by increasing, exhaling that excess CO2. So we would increase breathing. The other word you could write for this is hyperventilate. Okay? Now, last thing, what happens to your breathing rate if you accidentally inject yourself with NaOH, which you would never do, but for fun. Let's explore this. So, let me erase all the stuff I had right here. All right, how in the world would NaOH affect this whole reaction up top? Well, NaOH is going to make sodium and OH minus. Okay, now remember, this is a blood buffer system. So when you add strong base, how does a buffer respond? Okay, an acid would react with it. The only thing we have here that sticks out to me that would react with OH minus is H plus. Okay, so you can think of it like this. I'm gonna zoom into this corner and draw something up here. OH minus produced from the sodium hydroxide is going to see the H plus will see it, and they will react together to make water. Okay? So what that's going to do is that's going to use up some of this H plus. It's going to use it up. It's going to steal it away from our blood buffer system. So the amount of H plus is now going to go down because it's going to be used up reacting with that sodium hydroxide. Okay? So if that goes down, equilibrium, our blood, to replace the amount that's being taken away, will shift to the right. If equilibrium shifts to the right, how does that affect CO2? The only way equilibrium can shift to the right is if these things react together to make more product. Okay, that is what will result in equilibrium shift to the right. And so if we're using up some CO2 to shift equilibrium right, CO2 is going to go down, the amount of CO2 in the blood. Okay, so that's going to decrease the amount of CO2. We're using it up to shift equilibrium right to replace the H plus. And how's that going to affect your breathing? Well, if you have low amounts of CO2 in the blood, you're not going to want to exhale even more CO2. That would just take even more CO2 away. So we're going to decrease respiration to try to restore the diminished CO2 concentration. So you would decrease respiration. Or you could say you would hypoventilate. Okay? I think that's the last slide I had here. So that walks us through the blood buffer system. Definitely be ready for questions like this on the exam. And walking through Le Chatelier's principle, equilibrium shifts left or right, telling me how that would affect pH or how that would affect your breathing. Please reach out to me with questions if you have Any questions on pH, buffers, or this blood buffer system, and I'm happy to answer those. We will have a review on Chapter 10